A class, this is Ms. Roberts at Shasta High School. Tonight we're going to be looking at questions 58 through 63, I think, 58 through 63. So let's start with 58. It says graph the inequalities below on graph paper. Oh, to the graph paper, quick, here they are. First one we're going to graph is y is less than or equal to the opposite of x plus 5. So we've got this slope of negative 1 and a y-intercept way up at positive 5. So I'm going to start at positive 5 with a single dot, and then I'm going to go down 1 and to the right 1, right? Down 1 to the right 1. So these points are forming, they're all forming that slope pattern of negative 1. So that comprises the line. If I grab this, I can line this up. Now, this particular boundary line is going to be solid because it says less than or equal to the line. So I'm drawing a solid boundary line. And now with that boundary line drawn, I'm going to test a point. But this is y's by itself, and it's on the left-hand side. And it is saying y's are less than or equal to the boundary. So I'm pretty sure it's shaded below. But just to verify that, I'm going to test the point 0, 0. And you can see at this point, x is 0 and y is 0. So if I put both of those in, I get the statement, is y less than or equal to 5? And the answer to that is yes, it is. That means that we are shading everything below this. So the region that should be shaded for this graph is all the points below this boundary line, including the boundary line, are solutions. Let's move on to part B. It says graph y is greater than 2/3 x plus 1. So I've got a y-intercept that lives at 1 right here. And I have a slope pattern of up 2 over 3. And then from there I could go up 2 over 3. Oops, I was wrong. The y-intercept is at negative 1, isn't it? Yeah, on my book it says 2/3 x minus 1. So got the wrong y-intercept there. We need to have a y-intercept at negative 1 and then up 2 over 3 units, up 2 over 3 units, up 2 over 3 units. So there we go. This particular boundary is not solid because it says y's are strictly greater than this. So I'm going to do a dash line indicating that this boundary line, these points on the line, are not included in my solution. It's just basically kind of, it's a line of demarcation between where the solutions are and where they are not. I can test the point 0, 0. It's just slightly above this. So on this point, x is 0, and of course, y is 0. And if I was to plug in both of those points into there, this would say 0 is greater than negative 1, which is true. So I can see this pattern again where it says y's are greater than the boundary. So the last one said y's were less than it, but I am shading everything above it. So my solutions are all the points that live above this boundary line, but not including the boundary line. Let's move on to question number 59. It says solve each equation. Be sure to determine and check all solutions. So let's start with A. So this is an absolute value equation. That means that there are two things I should consider, right? I want to know, because again, I'm using this idea of looking inside. If I'm getting in the absolute value of something is 39, that means that that thing inside, right, the 9 plus 3x, could either equal negative 39 or positive 39, right? So either 9 plus 3x was 39, or it is the case that that 9 plus 3x was negative 39. So same two steps. I'm going to subtract 9 from both sides. So that gives me that 3x is 30. Therefore, x is 10 should be one of my solutions. Or if I take away 9 here, I've got that 3x is, negative 48. And if I divide by 3, I get x is negative 48 thirds. And I believe that 48 divided by 3 is 16. So that means that x is negative 16. So there are two solutions. for this problem, right? And I probably should write it all together. X is either 10 or X is negative 16. So these two together. Now, a check of those solutions. Let's see, if I was to put in 10 first for this X, that would be 3 times 10 is 30. 30 plus 9 is 39, and the absolute value of 39 is most definitely 39. If I put in negative 16, 3 times negative 16 is 48, and 48 plus the number 9 is negative 39. And the absolute value of negative 39 is also 39. So that's the solution for A. Let's take a look at B. B has the absolute, this again, the idea is looking inside, right? So that means that either the negative 3x plus 9 was 10, or the negative 3x plus 9 was negative 10. So that thing inside the absolute value was either a positive 10 or a negative 10 to produce this answer. If I subtract 9 and then divide both sides by 3, in the first case, subtract 9 gives me 1. So negative 3x is 1, so x is negative 1/3. Or, same thing, divide by, or subtract 9, negative 19, so negative 3x is negative 19, and therefore x is negative 19. Negative 19 over negative 3, which would be positive 19/3. So my answer, I believe, is negative 1/3 and negative 19/3. And if I try that, the thirds looks a little messy, but when I plug it in for the x, since I'm multiplying by negative 3, it's fine, right? Negative 3 times negative 1/3 is just 1, and 1 plus 9 is 10. Absolute value of 10 is 10, so that checks. And for the other value, negative 3 times 19/3 is going to be negative 19. Negative 19 plus 9 is negative 10. Absolute value of negative 10 is 10. So for B, we have the answer, for B, we have the answer that, oh, I'm not even using the good microphone. That's okay. Sorry about the sound. Let me plug this in. So for B, we have the answer, I hope I have audio now. X is negative 1/3, or X is 19/3. There they are together. And for the last one, I just want to point out that this says the absolute value of some expression is negative 2. What? Right? So if you take the absolute value of something, I know from experience that I'm never going to get a value of negative 2. So for C, we're just going to say that's not possible. There's no solution. So for C, there is no solution. All right, let's move on to question 60. Algeria has decided to take out an advertisement in the UN newspaper, Liberty Daily. The newspaper charges a basic fee of $1,200 for an ad. There is an additional fee of $300 for every inch in height. If Algeria is willing to spend any amount up to and including $27,000, what choice does the country have for the height of the ad? So it says there's an additional fee for every inch in height. So what constitutes the fee is you've got the $1,200, right? Plus, if X is the height, I'm gonna say, let's write a let statement. Let X be the height, HEIGHT, of the ad. Then $1,200 plus $300 for every height of inch. It has to be less than or equal to $2,700, right? Because it says they're willing to spend any amount up to and including $2,700. So what I'm saying here is this expression is how much they're spending, and that amount can go as high as 2,700, but it can't exceed that. It can be 2,700, but it can't be more than that. So if I want to solve this inequality, I honestly, I'm going to subtract 1,200 from both sides and divide by 300. So I've got $2,700 minus $1,200. Doop. And then I'm going to take that and I'm going to divide it by $300. And I get 5. So that means that X has to be less than or equal to 5. That means that they can get adds that if in whole inches, right? I guess you can get 1.5 inches, but 1 inch, 2 inch, 3 inch, 4 inch, and 5 inch. Or you could say it another way. If it's all those ranges in between, it could be, who would get an add that's 0 inches high? You couldn't see it. So I would say 0 up to and including 5. So this idea is called interval notation. This curve bracket means that it starts at 0 but doesn't include the 0. And when I use this bracket, it means it does include that endpoint. So in this notation, this would be equivalent to me saying, look, here's the number line, here's 0, that's an open boundary, and here's 5, here's 5, it's a closed boundary, and it's everything in between those two. I was going to highlight, it would be everything from 5 all the way down to the 0, but not the 0, right? It couldn't be 0 itself. Not a notation that I've said that you have to be able to use, but basically the answer to this add is, well, the height of the add has to be less than 5, so it could be any height between 0 and 5. And why do I stop at 0? Because I've never seen the height of an add that's negative 5 inches tall. I don't understand that. Okay, if the graph of an exponential function passes through 2 points, write an equation for this function. Well, that's sweet. So I've got 2 points. Each of them have an x and a y. This is an x here. This is a y. And I'm going to write the exponential equations in the form y equals ab to the x power. I'm not going to consider shifting that up or down with a plus or minus c, but we'll just do y equals ab to the x. And I'm going to plug in the x value from each and write 2 equations. So the first equation I write is going to be not y, but from the first point there, 6 is equal to ab to the first power. And then I'm also going to write 48 equals ab to the fourth power. Fabulous. Now, I'm going to solve this by isolating the variable a and then setting those 2 expressions equal to each other. So in the first equation, if I want to get a alone, I'm going to divide both sides by b to the first. So this is going to give me that 6 divided by b is a. You can see I just divided both sides by b to the first. Same thing for the second equation. I'm going to divide both sides by b to the fourth. So this is going to give me 48 divided by b to the fourth, and that is a. So certainly it is true in the context of this problem that a is equal to itself. And I have 2 expressions that equal a, right? The top one, which is 6 over b, and the bottom one, which is 48 over b to the fourth. I'm going to set those 2 expressions equal to each other. So I'm going to write 6 over b is equal to 48 over b to the fourth power. The next thing that I'm going to use is use fraction busters. I'm going to multiply both sides of this equation by b to the fourth power, by b to the fourth power. When I do that, the left-hand side is going to become simply 6b cubed. Think about it. Right? B to the fourth divided by b. Right? B to the fourth. Right? When I multiply by b to the fourth, that's pushing that across the numerators. B to the fourth over b is b cubed in the numerator. So I've got 6b cubed, and that equals the number 48. If I divide by 48, I get b to the third is 6 times 8, I believe, is 48, right? 6 times 8. So 48 divided by 6 is 8. That's one of the few cubes I know. I know 2 times 2 times 2 is 8, right? 2 times 2 is 4 times 2 is 8. So that means that B is 2. Great. B is 2. Another way you could get that if you didn't know it, you could take, if I wanted the, this is two ways to get it, right? I could take the cube root of 8, or I could raise 8 to the 1/3 power. 8 raised to the, up to the exponent of 1 divided by 3. So this calculator does a really good job of putting that division problem in the exponent very clearly. It's 8 to the 1/3. Be careful with your calculator because it may do 8 to the first and then divide that by 3 or something like that. But this is 8 to the 1/3, and you can see when I do it, it says 2. Alternately, if I wanted to do the cube root, I can, on this calculator, I could hit 3, and then I could hit math. There is a cube root 3 by itself, but if I hit 5, it'll take that 3 and make it the root index. So this is the cube root of, and then I hit an 8, and it'll say 2 also, right? So the cube root of 8 is 2. That means B is 2. 2 times 2 times 2 is 8. Now I need to figure out what A is, and that's pretty simple because if you observe right here, it says, oh, A is just going to be 6 divided by 2, right? So A is 6 over 2, so which is 3. So that means that A is 3. And you could get that the other way also. You can take 48 and divide it by B to the 4th. B to the 4th is 2, 4, 8 is 16. 48 divided by 16 is also 3. So in both cases, we have A is 3, B is 2. So now we're ready to write our answer, right? Remember, we're looking for something in the form y equals AB raised to the x power. We know that A is 2, so I write y is equal to 2. Nope. No. A is 3. It's right here. Look at it. Okay, I see it. Pay attention. Y is equal to 3 times 2, that's B, raised to the x power. So this is the equation in the form y equals AB to the x that will go through the 2 points given. By the way, it's a fun thing to just check that, right? If I put in x is 1, it should give me 6, and I can see that it does do that. Also, if I was to put in 4, it should give me 48. All right, let's move on to 62. Each team in Miss Zielinski's biology class is growing oyster mushrooms. Okay, the weight of several specimens was recorded along with the number of days of growth. The data was collected. The data that was collected is shown in the table below. Sweet. Make a scatter plot for the data and sketch it on your paper. Use time as the independent variable. Describe the association with each other. Okay, so I guess it's a good opportunity to review the use of this calculator to handle it. Desmos is pretty fun, right? You could use Desmos, and honestly, it's quicker. But I'm going to go ahead and do this with the calculator. So first thing I'm going to do is I'm going to go to Stats and Edit, and I can see, I've already got some data in here. So I'm going to move the cursor up to the very top. When it's up on the list 1, that's when I press Clear and Enter. And I'm going to go over to the other one. I'm going to go up here and hit Clear. Clear and Enter. So list 1 and list 2 are completely cleared out. So time is going to be my, interesting, 8.6 days. That must have been, they'd be recording hours, right? It's 8 days and a quarter of a day or something like that. So let's go ahead and record the days of growth down. So I've got an 8.1. Nope, I'm wrong already. 8.6. Let me pause the video. Okay, so I have a total of 9 data points. I had 9 x values that I entered in list 1. So these are in L1. They're my x's because they said use time as the independent variable, and my y's I entered in L2, and those are the weight in grams of the mushroom. So first of all, let's make the scatter plot for this. I'm going to go ahead and hit second, go up to the blue scatter plot. I can see my scatter plot is already turned on, and on it I am graphing, it says list 1 and list 2, so that's correct. The next thing I'm going to do is I'm going to press, I guess I'll hit second quit, then I'm going to hit zoom, and number 9 is zoom statistics. So it should create There we go, zoom stat. It should create a scatter plot. There we go. Oh, well, I could just say, just right off the top, right, that does not look like I want to fit a line with that, right? So, so what does it say? It says, make a scatter plot for the data, sketch on your use time. Okay, describe the association. Well, it definitely appears that as time increases, the weight of the mushrooms increases, but not in a linear fashion. It appears that the weight appears to be growing exponentially. It's not linear. So if I was to sketch this, of course, just here's my x, here's my y value, and just a quick sketch, I can see like a couple points, and then here, and then here. And I got the 1, the 2, and the 3. So definitely does not look like a linear relationship, right? In fact, if I was to look at the residual plot, I would see that typical high and then low and then high pattern. So there's going to be some kind of an exponential curve that would fit through this that would be better. But I would say that when I'm writing this down, as time increases, the weight of the mushrooms increases. However, it doesn't appear to be doing so in a linear fashion. It appears that the weight is growing faster over time. So B says the weight of the mushroom depends on growth over time. What kind of equation do you suggest to model this data? Well, I would say an exponential equation. Model the data with a regression equation. Notice it doesn't say least squares regression line. It says a regression equation. Does the y-intercept of your model make sense in this context? Okay, so let's take a look at that. If I was to go ahead and do that, so I'm going to hit, let's go ahead and find the line that fits. So I'm going to hit stats, go over to calc, and I'm going to go down to exponential, not logarithm, there we go. So I'm going to do 0, and I go down, and there we go. And it came up with the following equation. It says the equation is y equals 0.08 times 1.67 raised to the xth power. So it's like growing by 67% per day. And the question says, what it says, does the y-intercept of your model make sense in this context? Well, no. Right. I would think on day 0. I mean, obviously there's mushroom, what is it, spores? They're very, very lightweight, right? I don't know that I could detect their weight with any skill that I have. So I would expect the y-intercept to be 0 or much, much closer to 0 than it is. So no, I don't think it quite makes sense. And then it says, what do you predict an 8-day-old oyster mushroom will weigh? Use appropriate precision in your answers. So I'm going to say, first of all, based on the data set I was given up above, I should probably be rounding everything to the nearest 10th. So I'm going to do that. I'm also going to do, let's see, I guess I'm just going to take and I'm going to just put this 8 into this equation, right? I'm just going to evaluate this when x is 8. So I'm looking at 0.08 times 1.67 raised to the 8th power. And when I do that, I get about 4. What does it say? It says, what do you predict an 8-day-old? Okay, so I predicted 8 days. It should be about, that's interesting. For x equals 8, the model predicts 4.8 grams. So if it's predicting 4.8 grams, I think that's probably a little bit above, well, it's definitely above that one. I guess I really can't talk about the residual because I don't have an actual value for 8 anywhere on the chart, right? I'm just saying 8 wasn't there, so I'm predicting 4.8 grams. So I would say at day 8, I would expect an 8-day-old oyster mushroom to weigh about 4.8 grams. And that was certainly a fun problem. I enjoyed that thoroughly, and I'm going to investigate oyster mushrooms more later. Next, 63. On a coordinate grid, graph some points right here. Okay, so to save time, I went ahead and did that. The video paused. And honestly, the thing that always terrorizes me is just the idea that I could have incorrectly plotted these points. So I've double checked it, and I'm triple checking it right now while the video is running. So point A should be at -3, -4, right? When x is -3, y is -4. B should be at the point -1, -6, and C should be at -5, -8. Right, that's what I think it was. Yeah, -5, -8. Good. First question is, what is the length of segment AB? So we are asked to calculate the distance from here to here. And if I do that, I can see that I've got, I need to look at this right triangle with this leg, and those legs are both the same, right? So we're looking at a 2 and a 2. So if I'm looking at the length of segment AB, I would just write it like that. That's the length of segment AB squared equals I'll do the vertical leg squared, which is 2 squared, plus that horizontal leg, which is also 2 squared. So we're saying the square of the length of that segment is 4 plus 4, or 8. That means that the length of segment AB is the square root of 8. And if I was to write that in simplified radical form, that root 8 is 2 times 4. So I would say, well, that's the same thing as 2 times 4. And I could break that up. That's the same thing as the square root of 2 times the square root of 4. And I do this because the square root of 4 is rather pleasant. It's just the number 2. So this is equal to, I'll write the square root of 4 first, which is 2 times the square root of 2. So this is the simplified radical form that we've discussed a few times in class. And it really is a preferred form of the answer. There's a decimal equivalent to it, and certainly root 8 is equivalent to it, but 2 root 2 is probably the gold standard answer. Next question says, let's see, reflect this triangle across the x-axis to form A prime, B prime, C prime. What are the coordinates of B prime? Describe the function that would change the coordinates. Describe the function that would change the coordinates of ABC to A prime, B prime, C prime. Ooh, that's cool. That's cool. So let's look at this, the original triangle here. And I guess for convenience, I'm gonna erase that little slope triangle. Let me go ahead and highlight the big triangle that we're talking about transforming. So it's this triangle. And we're going to reflect this thing across the x-axis. So if you look at this, A is going to have the same across the x-axis. So I'm reflecting across x. X's are all going to be the same. What's going to happen is the y's are going to become opposites. So instead of going down to -4, this is going to go up to +4. So we should have -3 and a +4 is the first point. So this is going to be my A prime. And then B was at -1, -6. It's going to go -1 and then +6. So here is my B prime. And then finally, C was at -5, -8. So I'm going to go -5, and then I'm going to go to +8. So this is the C prime. So this is the triangle that results after this reflection, this one up here. And it said describe the functions, right? Well, in general, the function looks like this. I don't know how I would write this as a function. I guess I could write it as, I could say this. How could I do this? I could say this. I could say, look, the XY pairs get transformed like this. The x's stay the same, but the y's become the opposite of what they were, right? So I think this is how I would write this. X's stayed the same. So you can see the -3 stayed the same for both A and A prime. -1 stayed the same for both B and B prime. And -5 stayed the same for both C and C prime. What happened was that the y's all became the opposite of what they were. They flipped over. It feels somehow related to the absolute value too. I don't know. Maybe not. I have that thought. Let's move on. It says next. Now it says rotate. This is the triangle we just left off at. So I'm taking the A prime, B prime, C prime, and I'm going to rotate it 90 degrees clockwise about the origin to form another triangle. Oh, I forgot to answer. It says, what are the coordinates of B prime in that last one? So the coordinates of B prime are -1, +6. So this is important. -1, +6 is the coordinates of B prime. Okay, so now it did say take this triangle, right? The prime one, and rotate it 90 degrees about the origin. So one of the things I love about the 90-degree rotation about the origin is what happens with slopes. And I've talked to a few of you about this kind of recently in class. But if I look at like A right here, this slope pattern, if I draw this line back to the origin, this slope pattern is like down 1, 2, 3, 4, and then over 1, 2, 3. So that is a -4/3 slope pattern. Well, when I rotate that line segment that I just drew, the one I drew in white, and I'm going to highlight it in this yellow, when I rotate that 90 degrees about the origin, it has to make a right angle right there. Well, I know opposite reciprocals make the right angle, so that means I'm going to flip the 3, right? And then it's going to go over 4. So right now it's -4/3, but it's going to become +3/4. So from here I can go up 3 and then over 1, 2, 3, 4. This point right here is going to be my A double prime. And I can see this, I can even see it when I draw this, right? If I look at this line right here, I can see this is clearly, oh no, I didn't want to do that. Let me put that back. When I draw that line, this is clearly making a 90-degree angle back to the origin. So when I rotate this whole thing 90 degrees this way, it's going to land right at that spot. So really a cool way to think about that is the fact that slopes, after you rotate 90 degrees, the slopes are opposite reciprocals. So there's my A double prime. Let's see if I can do that with the B. So the B, let's pick this blue color. If I draw the line down to here, this has a slope of, what is it, down 6, -6 over 1. That means I'm going to go up 1 and I'm going to go over 6. So up 1 over 6. This should be the location of B double prime. And then for C, I'm all out of colors. So let's use this beautiful purple pen. That's barely visible. Anyways, from C I go down, was it down 8 and then over 5? So I'm going to go up 5 and over 8. Which up 5 over 8, which is right there. Great, let me put a dot right there. So this is my C double prime. So you can see my third triangle here on this sequence of rotations is this one. So I did this reflection across the x-axis, and then I did this rotation of this whole thing 90 degrees. My center of rotation was around the origin. This last question said, what did it say? Find the coordinates of, what are the coordinates of C double prime? So C double prime is located at 8, 5. Here we go, 8, 5. All right, and then last question it says, translate, this is now my original triangle, right? So when they say this, they're like, okay, go back to your original ABC, translate it so that your xy's behave like this. Your x's are going to be increased by 8, and your y's are going to be increased by 6. Okay. And then describe the translation as the movement a certain distance along a line parallel to the line of transition. Okay. I think I can explain what they're talking about there. So x's are going to go, let me write this down, x plus 8, and the y's are going to increase by 6. So if I'm looking at this, let's do A first. I'm going to erase all this so I have room for it. So if I look at point A, it's here, and I'm going to increase the x value by 8. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go up 6. 1, 2, 3, 4, 5, 6. So this triangle is going to get in the way of that A double prime, B double prime, C double prime, but oh well. Okay, and then that's where this newest A is from, and I'll do these all in this purple color. And then the next one is going to go, the B is going to go over, it's the same, right? X is going to increase by 8, so it's 1, 2, 3, 4, 5, 6, 7, 8, and then it's going to go up 1, 2, 3, 4, 5, 6. So this is the new B. I'm not even going to call it B. I can't call it B prime because that's already taken. I'll just say this is the new B, right? Just over 8 up 6. And then finally C, same deal. I'm going to go over 8. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go up 6. 1, 2, 3, 4, 5, and 6. So this is the location of this new C. So this triangle heads out here. Now, the question that they're asking me is, look, what did I do every single time, right? Every single time, if you look at the original triangle and look at this new one that resulted, right, I'm translating along this line right here, this line. Draw that, this line. And in fact, every single one of these, when I connect them, like B, this most recent B to this one, all these lines are parallel to each other, and this C to this C, they're all parallel to each other. Well, what is that line every single time? Well, it was the same thing, right? If I think about it, I'm traveling a certain distance, right? This distance right here is the distance that I'm traveling. Well, what is that distance? Well, it's 8 along this side, and it's 6, right? 1, 2, 3, 4, 5, 6 along this side. So every single time, how far am I traveling? Well, it's like taking this whole triangle and scooting it this direction by how far? Well, that's going to be the length of this hypotenuse. And I'm just going to say that the distance we're traveling there, for argument, I'm just going to call it, I can't call it x because it's contextually that would be like, wait a minute, x on the x-axis, what are you talking? I'll call it C. I got a point called C. I'm going to call it W, right? I'm going to call this W. So how long is this line W, right? How long is that? Well, it's going to be 8 squared plus 6 squared, and then the square root of that. So I can say W squared is 8 squared plus 6 squared. W squared is 64. 8 times 8 is plus 36, right? 90, is that 100? W squared equals 100. And then that means if I take the square root of that, W is 10. So that means I'm traveling 10 units. I'm taking this whole thing and I am sliding it 10 units parallel. What did it say? It's parallel to what line? What line is it parallel to? Well, it's parallel to the line. Oh, does it say a line that goes through the origin? Parallel along a movement a certain distance along a line parallel to the line of translation. Okay, it said a line parallel to the line. Okay, so what is a line parallel to the line of translation? Well, a line would be any line with the slope of up 6 over 8, right? 6, 8, which is, well, that's 3/4, right? So any line that has that slope, so y equals 3/4 x. So you can say that I am traveling 10 units parallel to that line. So every single point gets pushed along 10 units along that direction. What a mess I've made of this. I'm sorry about that. It's so messy. All right, last question. 64. It says line L is perpendicular to this line and passes through a point. Line M is parallel and passes through this point. Where do those lines? This is a gold problem. I've never seen such reason for celebration so late in the evening. That's a great question. So first of all, I need to figure out what line L and line M really are. So line L is perpendicular, right? Perpendicular to this line. So I need to figure out the slope of that line. Okay, well, let's put it in slope-intercept form. So this would be negative y equals negative 6x plus 7. So what I did is I subtracted 6 times x from both the left and right hand side, and now I'm going to divide both sides by negative 1. So y is equal to 6 times x minus 7. So that's the slope that I'm dealing with, is the slope of 6, but it's got to go through the point 0, 6. Well, that's fun because this point, that is my y-intercept, right? So this is super easy. So I can tell you I know about line L. L is this line. L is the line that has the equation y equals 6 times x plus 6. I got the slope because it was perpendicular. Ooh, I just almost botched that, man. Perpendicular, the slopes have to be opposite reciprocals. So this slope has to be negative 1/6. Negative 1/6 is the slope of line L. Yeah, because it says clearly, Mr. Roberts, it's perpendicular. So it's not 6, it's the opposite reciprocal of that. So the line L has a slope of negative 1/6 times x, and it has a y-intercept at 6. Okay, M is parallel to this line. Okay, well, if it's parallel, now I can just copy the slope. The slope of line M is 2/3, and it has to go through this point 3, negative 3, negative 1. So let's think about that point. So I'm looking at y equals mx plus b. Y from this point is a negative 1, and that equals this slope 2/3 times x, which is a negative 3, and then plus b. Okay, so let's simplify this. So negative 1 is negative 2 plus b. Yeah? Yeah? Because that's like negative 6 over 3, which is negative 2. Add 2 to both sides, I get that 1 is b, so my y-intercept is 1. So this other line, line M, right, has the equation, line M, I'll put a box around it. This line has the equation y equals 2/3 x, because it was parallel, and then it would have a y-intercept of plus 1. All right, so those are my two lines. What the question now asks is, it says, what is the point where that line and this line intersect? They didn't give me those lines. They gave me enough information to get the lines, but now the question is, well, where do those lines meet each other? Well, let's use the equal values method. They're both in y equals form, right? So we'll take the line L's y, which was negative 1/6 x plus 6, and then we'll take line M's y, which was 2/3 x plus 1, and let's multiply both sides of this by, let's push a factor of 6 across the whole thing, right? So both sides, every single term is going to get a new factor of 6. When I multiply negative 1/6 times 6, negative 1/6 times 6 is going to give me a negative x, and then plus 6 times 6 will be the 36. 6 divided by 3 is 2, so 2 times 2 is, this should be a 4x, and then plus another 6. Okay, only the variable I have here is x, so this is the equal values method. I set the y as equal. Let me add x to each side, so this is 36 is 5x plus 6. Subtract 6 from both sides, so 30 is 5x. Divide by 5, 6 is what x is. And now that I know the value of x, I need to plug in to figure out what y should be. So I'll ask this equation. 2/3 times 6. 6 divided by 3 is 2, times 2 is 4, so this is going to be 4 plus 1. So this equation tells me that y should equal the number 5. So that means together my solution is lines M and L meet at the point 6, 5. And that point, when I found y, I checked that with line M, but I think I should check it with line L also. So let me take that value of x6, and 6 times 1/6 is -1, and -1 plus 6 is 5. So it works in both lines. That is the point where these lines meet, and hopefully they're the right lines, right? I mean, I almost made a big mistake with L because I used the slope that I would use if they were parallel to each other. But when I solved that first equation, 6x minus y is 7, I got a slope of +6, so that means the slope we needed was -1/6. Caught it just in time. All right, that's it for this assignment. I'll see you in class.